Assalamualaikum and hi students. This is a lecture video for BMCG 1013 Differential Equations. The last video for chapter 3 Laplace Transform. Okay, at the end of this video, you should be able to apply the Laplace Transform in solving the initial value problem, and we will try to solve the transfer functions problem using Laplace Transform. 3.4 Solution of Initial Value Problem. Okay, in solving initial value problem using Laplace Transform, we have these 5 steps. Okay, so the first step is to rewrite the equation a d square y over dt square plus b dy over dt plus cy equal to ft in term of Laplace Transform. So you need to find what is the Laplace Transform for this a y double prime plus by prime plus cy, and you know that ft. Okay, if you have ft, you find the Laplace Transform for ft, you have fs. For the second step, you need to insert the given initial value problem, initial condition, y0 and y prime 0. And the third step is to rearrange the ys equation. Okay, and the fourth step, determine the inverse Laplace transform. Okay, find what is inverse Laplace for ys so that you have yt in step 5. In order to solve for the initial value problem, you need to know this substitution. Okay, for transform of derivative, okay, from the definition of Laplace transform, you know that yt is equal to ys. Laplace transform of yt is ys, and Laplace transform for y prime t is this, as ys minus y0. Y double prime t is equal to s square ys minus sy0 minus y prime 0. And in general, we write y and t is equal to this substitution. You need to know this. You need to remember this because we will use this in solving the IVP. Example 3.12. Okay, solve the equation dx over dt plus 2x equal to 10 exponent 3t given that when t equal to 0, x is equal to 6. Okay, so start with the first step. In the first step, you need to apply Laplace transform for both sides. So you have Laplace you need to find what is Laplace transform for x prime plus 2x equal to Laplace transform of 10 exponent 3t. Okay, so Laplace transform for x prime is equal to s xs minus x0 plus Laplace transform for x is 2xs. Refer to this. Okay, substitute what is y prime and y equal to Laplace transform of 10 exponent 3t is equal to 10 1 over s minus 3. And then in step 2, you need to substitute the initial value problem given. Okay, so s xs minus x0. 0 is equal to 6. So x0 is equal to 6 plus 2xs equal to 10 minus s minus 3. Second step. Moving to third step. In third step, you need to rearrange your xs. So you have xs s plus 2 equal to have 10 minus s minus 3, and then you need to move your negative 6 to the right hand side plus 6. Then you have xs is equal to 10, then move your s plus 2 to the right hand side. You have s minus 3, s plus 2 plus 6 over s plus 2. You are done with step 3. Continue with step 4. Step 4, you need to find the inverse Laplace of xs and inverse Laplace of this term. Then s minus 3, s plus 2 plus 6, s plus 2. Okay, so inverse Laplace of xs is xt equal to inverse Laplace of 10 over s minus 3, s plus 2 plus inverse Laplace of 6 over s plus 2. Now what you have to do is to find the inverse Laplace of these two terms. Okay, solve one by one. Okay, let's start with this first term. Okay, you have 1 over s plus 2 product with 10 over s minus 3. So you can use convolution theorem to solve for this multiplication of 1 over s plus 2, 10 over s minus 3. So let's say my fs is equal to 1 over s plus 2. Gs is equal to 10 over s minus 3. Okay, so I find what is ft. My ft is exponent negative 2t, and my gt here is equal to 10 exponent 3t. Once I have my ft and gt, I need to find what is fu. Substitute t with u, so exponent negative u, and gt minus u. For this, I have 10 exponent 3 t minus u using convolution theorem. And then I have to solve for the integration 0 to t fu exponent negative 2u multiplied by gt minus u exponent 10 exponent 3t minus u du. Okay, so I have 10 0 to t exponent 3t minus 2u minus 3u minus 5u du. Okay, integrate this. I have exponent 3t minus 5u divided by negative 5. Next, I need to substitute the value of u. Substituting u value, I have exponent negative 2t minus exponent 3t. Substitute t and 0. So this is my last answer for the first term, the inverse Laplace for the first term. So I have 2 exponent 3t minus exponent 2t. Then continue with the second term, Laplace transform for the second term. Inverse Laplace of 6 over s plus 2. So this is s minus minus 2. So I have exponential 6 exponent negative 2t. So I can continue with my last step, step 5. Step 5, I have my xt equal to, okay, this one, 2 exponent 3t minus exponent 2t plus inverse Laplace of this is 6 exponent negative 2t. So this is negative 2t. Okay, missing the negative. So I have 2 exponent 3t. Simplify this, negative. So I have 2, 6, so plus 4 exponent negative 2t. Okay, so the Laplace transform for this x prime plus 2x equal to 10 exponent 3t is equal to 2 exponent 3t plus 4 exponent negative 2t. Next example, solve the equation d square y over dx square plus 4y equal to 24. given that y0 equal to 3 and y prime 0 equal to 4. We will solve this second order differential equation using Laplace transform. So start with first step. Okay. First step, substitute y prime and y, okay, into Laplace transform. So we have s square y s minus s y0 minus y prime 0, and then plus 4y. Laplace of y is equal to ys equal to, then we need to find what is Laplace transform for 24. It's a constant, so we have 24 over s. Second step, in second step, substitute the initial condition. So s square y s minus s y0. y0 equal to 3, so we have 3s minus y prime 0 equal to 4 plus 4ys equal to 24 over s. Okay, the third step, okay, find what is ys. So ys, okay, factorize ys, we have s square plus 4 minus 3s minus 4 equal to 24 over s. So ys is equal to, moving this negative 3s minus 4 to the right hand side, 24 over s plus 3s plus 4. And then move s square plus 4 to the right hand side. I have this s multiplied by s square plus 4, and this is s square plus 4. Okay. In fourth step, you need to find what is inverse Laplace of this ys. So inverse Laplace for ys is yt, and then find what is inverse Laplace of 24 over s square plus 4 plus inverse Laplace of 3s plus 4 over s square plus 4. Okay, again, we can solve one by one. Okay, for this one, it can be written as 12 over s multiplied by 2 over s square plus 2 square. So we have fs and gs. Let's say fs is equal to 2 over s square plus 2 square, and gs is equal to 12 over s. ft is sine 2t, we have 2, a and a, and gt is equal to constant 12. Okay, fu, for f we need to find what is fu, so it is sine 2u, and for g, gt minus u, it's still 12. Okay, so convolution theorem, 0 to t, sine 2u, sorry, fu multiplied by gtu multiplied by 12 du. So I have 12 integration 0 to t sine 2u du. Integration of sine 2u is cos, negative cos 2u over 2. Last, substitute the value for u. So you have cos 2t minus cos 0. Okay, you know cos 0 is equal to 1. So you have 6, 1 minus cos 2t. Cos 0 is equal to 1. Okay, so you are done with the first term. Okay, moving to the second term, this. Okay, so Laplace 3s plus 4 over s square plus 4 can be written as 3s divided by s square plus 4 plus 4 over s square plus 4. Okay, so this is equal to S over S square plus 4 is cos. So you have cos 2t because you have 4 here. And then in this side you have you have 4. So you have 2. You have extra 2 here. So 2 sine 2t. Okay. You have 2 over S square plus 2 square sine. And then you have extra 2 here. So you have 2 sine 2t. Okay. In step 5, we have the YT, the particular solution. 6, 1 minus cos 2t plus with 3 cos 2t plus 2 sine 2t. So YT is the solution for this second order differential equation. The last subtopic in this chapter, okay, we have 3.5 transfer functions. Okay, transfer function is the method to represent system dynamics, okay, in S-domain representation from Laplace transform. It shows flow of signal through a system from input to output. Transfer function we denote as HS, capital HS is ratio of output XS to input Fs. So we have HS equal to XS divided by Fs. Output to the input. Okay. Using Laplace transform, you use Laplace transform. And when you find the inverse Laplace of HS, you have HT. Okay, HT is impulse response. For input-output operation, it deals with steady-state terms which ignore the initial condition. Okay, when we have initial value problem, we can just ignore the initial conditions. Example 3.13, we try to solve the problem involving transfer functions. The first example, find the transfer function HS for the system that governed by the differential equations, given differential equations. Second order, okay, y double prime plus 4y prime plus 20y equal to ft. Okay, ft is the input and yt is the output. Okay, input and output, you have here y and f of the system. Hence, find the impulse response function ht. So first you need to find what is hs, and the second one you need to find what is ht, the Laplace transform, inverse Laplace for hs. Okay, we start with the first steps as usual. You know this is your second order ODE. Then find the Laplace transform for this y double prime plus 4y prime plus 20y. Okay, and Laplace transform for ft. Okay, Laplace transform for ft, you know it is fs. So this is s square ys minus sy 0 minus y prime 0. Substitution for y double prime plus 4ys plus 4y0. This is for y prime plus 20y is equal to ys equal to Laplace for ft is fs. Okay, now in transfer function, we will just ignore the initial condition. So ignore all this y0 and y prime 0. Okay, in second step, okay, you have s square ys plus 4ys plus 20ys equal to fs. So you can write your ys as s square plus 4 plus 4s. This is s. 4, yes, s, missing s. 4s plus 20 equal to fs. Now your ys is equal to fs over s square plus 4s plus 20. You have your ys now. Then you need to find what is the transfer function hs. So the formula for hs is x as the output divided by the input fs. So x, ys, in this problem, you have ys over fs. Substitute the value of ys and fs. So ys is equal to fs over s squared plus 4s plus 20. Then you need to divide by this fs. So multiply by 1 over fs. Okay. So your hs is equal to 1 over s squared plus 4s plus 20. Now you have your hs. You are done with the first task to find the transfer function. The second task is to find the impulse response, ht. So what you need to do next is to find the inverse Laplace of hs. So you have hs equal to 1 over s squared plus 4s plus 20. First thing you need to do is to do the completing the square for the denominator. So for this one, you have hs equal to 1 over s plus 2 square plus 20 minus 4. Completing the square, and it is equal to 1 over s plus 2 square plus 16. Okay. ht, for ht is equal to inverse Laplace of hs. hs is 1 over s plus 2 square plus 16. Okay. So this is your alpha is equal to negative 2. Okay. And your g s is equal to this 1 over s plus 16. Okay, you know this will be a sign if you have 4 over s square plus 16. So you need to multiply by 4 by 4. Okay. So gt is equal to 1 over 4 sine 4t. Okay. The last answer for ht, the inverse Laplace for this is equal to exponent negative 2t multiplied by 1 over 4 sine 4t. First shifting for inverse Laplace. So you have 1 over 4 exponent negative 2t sine 4t. Okay, you have the transfer function and its impulse response. The last example for this video, you need to find the output response xt for the system with the transfer function, given transfer function hs equal to 1 over s plus 2 square. And the input fs is equal to 2 over s cube. You need to find the output xt. Okay, so first you know that hs, the transfer function, is equal to xs over fs. Okay, so xs, find what is xx. Xs is basically hs multiplied by fs. Substitute h, 1 over s plus 2 square, and substitute fs, it is 2 over s cube. So xs is basically 2 over s cube s plus 2 square. You have your xs, find what is xt. So you need to find what is the inverse Laplace. Find what is inverse Laplace for this 2 over s cube s plus 2 square. Now, let fs equal to 1 over s plus 2 square. And our gs is equal to 2 over s cube. Okay. ft is equal to inverse Laplace of 1 over s plus 2 square. Okay, we can use the first shifting. So alpha equal to -2. F1s is equal to 1 over s square. So F1t is equal to t. Now ft is equal to exponent negative 2t multiplied by t. Okay. Then for gs, gt is inverse Laplace for 2 over s cube. So gt is equal to t square. Okay. We have 2 factorial divided by s, 2 plus 1, so t square. Once we have ft and gt, for convolution theorem, we need to find what is fu and gt minus u. For fu, we have u exponent negative 2u. And for gt minus u, we have t minus u square. Okay, expand this, you have t square minus 2ut plus u square. Okay, for xt, we have convolution theorem, integration 0 to t, exponent negative 2u, u exponent negative 2u, multiplied by t square minus 2ut plus u square du. Okay. So for this, you will need to use tabular method. Okay, tabular method to solve for this integration. You have polynomial, and polynomial should be on the left hand side, on differentiation side. So t square u, you multiply this u with all the term here. So t square u minus 2u square t plus u cube. And for integration part, exponent negative 2u. Okay. Then differentiate this term respect to u. You have t square minus 4tu plus 3u square. Then negative 4t plus 6u. Have 6, and last you have 0. For integration part, you have a negative 1 over 2 exponent negative 2u, 1 over 4 exponent negative 2u, negative 1 over 8 exponent negative 2u, and last 1 over 16 exponent negative 2u. Do not forget the sign. You have plus, minus, and minus sign. And then you have cross product. So now we have our output response xt equal to positive, negative, you have negative 1 over 2 exponent negative 2u multiplied by t square u minus 2u square t plus u cube minus 1 over 4 exponent negative 2u multiplied by t square minus 4tu plus 3u square plus minus, you have minus 1 over 8 exponent negative 2u multiplied by negative 4t plus 6u minus plus, so you have minus 1 over 16 exponent negative 2u multiplied by 6. Simplify this, you should get the last answer equal to 1 over 4 t square minus 1 over 2t plus 3 over 8 minus 1 over 4 t exponent negative 2t minus 3 over 8 exponent negative 2t. Okay, so now you find what is the output response. Okay, you have the xs first, and then you got your xt at the end. Okay, so that's all for chapter 3, Laplace Transform. In my next video, we will start exploring what the new chapter, chapter 4, Fourier series. Thank you.